We today are going to discuss about optimizing React Native and mastering component efficiency. So let's get started. Here, the first thing that we're going to take up is why. Why is optimization essential for us? So, since React Native has become increasingly popular today and is also growing, we need to ensure that the apps are efficient and have a very snappy user interface. And as the app grows in complexity, we face performance issues. Performance issues such as slow navigation, increased component hierarchy, state management challenges, and so many more about that. So the main bottlenecks that we face are usually slow navigation, janky animations, excessive render times, and network bottlenecks. Talking about slow navigation, we do notice that slow navigation occurs whenever we have heavy processing or there are like too many things to render at the same time. And janky animations are basically whenever we are trying to debounce throttle, whenever we don't use that, we do see some janky animations around that time. Excessive render times. So excessive render times do come whenever we have too many components in the same main component and we don't split the code. We don't see the efficiency if it is being done or not. We're just getting the things done, such as maybe we're using the main component for everything. Maybe we're using app.js, we're using index.js, we're using those for a lot of things. To avoid that, we will understand on how to do it. But first, we need to understand the need of it. The need of it is to ensure performance across diverse devices. Since there are a lot of devices in this world, a lot of different interfaces, a lot of different users who are using it with different networks, we do need to ensure that the performance is up to the mark because it will ensure the app success in the market, right? So, for that, we need to understand faster loading, we need to have efficient data usage, and we need to have a competitive edge in the industry as well. So let's come up onto how do we achieve that. So before we move ahead, let's go over a fun fact. Do you know how long a modern device takes to show 60 frames per second? It's 16.67 seconds. Sorry, milliseconds. That is the time limit we have to display a frame for a smooth and a very snappy user interface. So let's see how can we achieve that. To achieve that, the first approach that we're going to take is lazy loading. I'm sure all the React developers are very familiar with the approach, but React Native has also introduced that as well. And here we do see that while navigation, we face this issue that the navigation is slow, the app startup is slow. We see that Hermes does help in that, but lazy loading can enhance that performance, right? We can achieve that as in the right screenshot. You can see that there's a component that is called major component. We're using lazy loading to import that and a suspense as well right around here, right? Next up, we have image optimization. Now, since we discussed lazy loading, we're going to discuss image optimization as well here. Now, image optimization can be done by lazy loading, compressing the image on the server side, caching the image as we have done over here using React Native image cache, wherein we are sending the source, the styling, and the thumbnail source. Along with that, we also have fast image, with which we can achieve that using React Native fast image. Here on the right side, you can see the example that displays that fast image. In the fast image, we can provide the source wherein the URI is provided, the priority of the image is provided, the styling is also provided with it. But there's a drawback to it. The drawback is that there's no support or there's a lack of support of .svg format, which a lot of industries do use that. So this would lack in that. So I would like, as a personal opinion, I do prefer caching the images first. And moving on, we have like the most underrated approach, that is code splitting. Code splitting is also done in React. A lot of us are familiar with that. Moving on, here we do reduce the initial bundle size and improve the startup time. It ensures that the app refreshes, loads the component whenever it is necessary. So here we are breaking down the code into smaller chunks, into smaller bundles, wherein we are able to split it and reduce the bundle size and reduce the time that it is taking to load. This is useful for underperforming applications. That would be huge applications that are not using this approach, or maybe are not on the latest React Native version. That's also a possibility. And also in modular applications. Now, modular applications can be something of the sort that there's an employee, there's an employer, and that there's an admin, right? We're trying to make a common application for all three of those. We can separate the user interface for them using code splitting. When at the time of login, we can ask them what is the user ID, right? The password. On that, we can decide on whatever code are we trying to load. And in that, when we have bundle sizing done and the bundles are made, we won't be loading unnecessary bundles as well. That would be the admin side trying to get the employee code or the employer code, right? Here we can see an example of the same, wherein we have account and profile data. We're trying to get the data of the profile using an API. That's a simple thing over here. In the return statement, we're using the count, we're displaying the count, we're showing the profile data. There's nothing wrong with that. We're using two use states, right? But there would be a situation where we would not have two use states. We would have 20, we would have 200, not 200 exactly, but yes, somewhere around 20. Even that is not suggested because it would lead to excessive re-renders. How can we optimize it? By code splitting. Here I have two of the states, that is count and profile data. I'll be splitting it into my component and profile data. We can see that over here that I've split the count to a separate component, and now I'm loading the profile data over here, wherein any changes that are being made in the profile details won't be reflecting or won't be affecting this component. Here we can see that profile details is there, and we are trying to get the response from the API over here and present it over here, right? So this, what did this prevent? This prevented the change or the reloading or the refreshing of the count that was over here. In the previous approach, we would have made a change in the count every time we were fetching the data, because it would have reset the states over here and it would have given it another refresh around it. Yeah. So there is another way of approaching this problem. We can use re.pack, that is a toolkit that we use to use Webpack and to use code splitting features. Now in this, we have a chunk manager with which we can make multiple chunks and divide the bundle into multiple parts, right? So when we divide the bundle into multiple parts, we do achieve the successful loading of the data whenever we want to load it, right? Now it allows us the creation of suspense, as I presented in one of the examples, based on chunks in the application. But what does it mean to use re.pack over here? It means that you're moving away from the Metro bundler. There are some leverages that we get with the Metro bundler, but if you are not using that, if you're not using those features, there might be this would be your solution to your problems or to even pace up your application. Next up, we have efficient virtualized lists. Now, everyone over here is aware of what a flat list is. We also had a question of that. Yes. So why would I suggest using a flash list over a flat list? It is because it is known for its optimal performance in even low-end Android applications. And unlike flat list, flash list uses the list items, but it does not reset the state in the use state hook. Now we had recently discussed on how does use state affect our performance, our application, our components re-rendering. This would help us avoid that. So there's an additional property which I would like to point out in flash list, which is an add-on feature after flat list. That is an estimated item size. It is a single numeric value that hints the flash list about the approximate size of items before they're rendered. Now, what does this mean for a flash list? It means for a flash list that you can tell the flash list that this is the number of items that it's going to load. It would have an approximate, and hence it would be ready to handle that kind of a load, right? What does a flash list do? It just gets you the data, whatever is required in the viewport, right? moving on, as we had discussed about Hermes engine, in React 0.73, we do have this as a default one. So Hermes garbage collection is there, and it is, I would highly advise to use that because it is designed to optimize memory management, reduce runtime memory usage, and improving the app responsiveness, right? So what does Hermes garbage collector mean to a developer? It means that whenever you're using the application, you might see things that are leaking, memory leaks that are happening, or maybe some bottlenecks that you're facing, right? So this would help you achieve that kind of a success that would not allow the application to have memory leaks, or maybe you could collect the garbage around that. Next, we could also leverage one of the features that is runtime optimization. It would include ahead of time compilations and bytecode pre-compilation, right? What does it mean? So what we were doing previously were we were compiling the code, and then we were sending it over to the system, to the React Native, the UI, to present it. Here, we are compiling it, and then it is directly going in wherever and whatever is necessary. That much is going in over here. So, what are the other strategies that would be there to reduce the unwarranted re rendering? As this was all about reducing re rendering, how else can we achieve it apart from these topics? There would be memoization. Now, memoization is using React.memo, use memo hooks to memorize expensive computation or prevent the re renders whenever the components dependencies remain unchanged, right? Next up is component optimization. Now, component optimization means utilizing pure components or HOCs, that is higher order components, to prevent the re-renders unless the component, so sorry, unless the components props have been changed, right? Next up, we have state optimization. Now, state optimization would mean avoiding the creation of unnecessary states, or even splitting a state into even smaller states, or even smaller variables, even smaller pieces, to limit the scope of re-renders. Now, there's another one, event handler optimization. Here, we would memorize event handlers or wrap them in use callbacks to prevent the recreation on each render. We can also use bounce, we can use throttling, we can leverage those and debounce everything that the user is maybe typing in. We can achieve that purpose. Next, we have selective rendering. Selective rendering is basically implementing should component update react.memo to selectively render a specific, to selectively render on based on specific conditions and specific requirements. We can render a component on that. This was basically similar to what we were trying to achieve previously with that purpose of code splitting with the chunk bundler. We can achieve it using that as well. So yeah, that's about it. And feel free to connect at my LinkedIn. Here's my handle. Thank you.